What do I mean by a prime number? Well, a prime number only has a few factors, doesn't it? Matter of fact, a prime number is a number that has exactly two factors. Two distinct factors. One in itself. For example, the number 5. 5 is prime. Its only factors are 5 and 1. What's the smallest prime? Okay, yeah. Let's talk about 1. 1 doesn't quite qualify for prime. Because how many factors does 1 have? It has one factor, okay. It needs to have two distinct factors to be officially called a prime number. So the smallest prime, that would be 2. 1's neither prime nor the other thing we'll talk about here in a second, but 2 is the smallest prime. 1's not prime. Okay, so we just start listing primes. Start with 2. Then we've got 3. Is 3 prime? 4? No. Now, that brings up the other little word there. 4 we call composite. And a composite number means it has more than 2 factors. And 4's got 1 itself and 2. So it has 3 factors. So any number that has more than 2 factors is composite. So 4 is not a prime. 5 is. 6 isn't, because 2 is a factor. 7 is. 8 isn't, because 2 is a factor. Matter of fact, what is 2 relative to the others? It's different. How is 2 different than the others going to be on this list? It's the only even prime number, isn't it? It's the only even prime number it could be, because if you get another even number, it's always divisible by 2, and so that rules it out from being prime. So the rest of these will be, one thing we could say is odd. Now, are all odd numbers prime? What about 9? 9 is not prime because it has 3 factors. 1, 3, and 9 are factors of 9. 11 is. 12 isn't. 13 is. Really just need to talk about the odds, don't we? 15, is it prime? Nope. 17, yes. 19, yes. 21, no. 23, yes. 27, 25, 27, 29. 29 is the next one. 25 and 27 aren't, because they're factors. And then 31 is, how far do I want to go? 30, it's going up to 50. 33, no, 3 is a factor. 35, no, 5 is a factor. 37 is. 39, 3 is try to divide by 3. 39 goes evenly by 3. So 41 and 43 and 47 is the list up to 50. The rest have some factor or another there. So the primes, and you could just keep going and keep going right there. Interesting little footnote we might make before we talk about a couple other things. If I make a list of numbers here, let's go 2 through 7 on the top. And then just keep going there. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Make it pretty long. Let's go out to 37. The way this works is this. I'm going to circle 2 because 2 is a prime number. Looking for primes here again. Well, 2 is a prime, then all its multiples are not 4, 6, 8, 10, 12. And if you'll notice there, those are all lining up. First column, third column, fifth column. I can mark out every one of those because those are all divisible by 2. The next number is 3. Do the same thing for 3. 6 isn't a prime then. 9 isn't. 12, already got it marked. 15, 18, but notice those are all going in columns 2 and column 5. I've already got that one marked out though. Which brings us up to 5. 10 then, mark it out. 15, 20, 25, 30, 35. And notice those are going on diagonal. There's some interesting little patterns here. But 37, the square root of it is 6.1 or 2 or something like that. I've reached that, so the rest of these are primes. The reason I do that, this little method here actually was known. Here's another little history lesson. This was it's called the Sieve of Eratosthenes, Greek person. Something like that. But this is kind of how they had set up to find prime numbers, and you can do it up to how many ever you want to get prime numbers. But the reason I like to do it is to show you a couple little things. Other than 2 and 3 here, do you notice something about the others? The others, and if we did this further on out, we would see the others, the prime numbers, are always either in this column or in this column. Interesting little, if you set it up this way, go 2 through 7 and then down from there. The prime numbers will always, besides 2 and 3, will always be in column 4 or 6. Now, you notice something about column 5 here. 6, 12, 18, 24, 30, 36. Those are all multiples of what number? Multiples of 6. Those are the multiples of 6. So do you notice here, other than 2 and 3, the prime numbers are always 1 less than a multiple of 6 or 1 more than a multiple of 6. Interesting little fact. Maybe you didn't know. But yeah, prime numbers greater than 6 are always 1 more or 1 less, and that works even beyond, like here, 41 is 1 less than 42. 43 is 1 more than 42. 47 is 1 less than 48. Prime numbers are always 1 more or 1 less than a multiple of 6, other than 2 and 3. Which 2 and 3, 2 times 3 is what? 6. Okay, and that's kind of playing a part of it too. But anyway, just an interesting little fact. And that's kind of what we're doing here with number theory, is just looking at some interesting facts on some numbers, counting numbers. But let's go back to a couple of things. So yeah, we can make our lists and determine if a number is prime, doing a list like this and just thinking about the ones. But let's talk about another way here. let's say we ask ourselves, is 89 prime? I didn't go that far up on our list, so maybe it is, maybe it isn't. How do we know? Well, we need to check factors of it, right? And this one isn't too terribly big, but let's think about it a little bit. Is 89 prime? I'm really asking, is there another factor other than 1 in itself that goes into that? All right, well, let's think about numbers I'd have to check. Have to check. Obviously, one you scratch right off immediately is 2. Is 2 going to be a factor? No, because this one's an odd number, so 2 is not a factor. But we did, in essence, check it just to make sure it's not an even number. That would be an easy. If I'd said, is 90 a prime, this conversation would be over, because no, 90 is not prime because it's divisible by 2. So anyway, you do check 2, but we need to check 3, wouldn't we? 3 we would have to check. Is 3 a factor of 89? I don't think so, right? It doesn't go evenly. You can check on a calculator, but it doesn't. Now, do I have to check 4? Is 4 going to be a factor here? How do I already know 4 is not a factor here? Because 2 is not a factor, 4 is not a factor. If 2 isn't a factor, then 4 certainly isn't. So there's no need to check 4 here, because I already know it's not a factor because 2 is not a factor. So I'm not going to write 4 as a have to check number. Now 5, I haven't really checked it yet, but 5's easy, and we'll talk about that more in just a second. But do I have to check 6? I don't really have to check 6 because that's the same thing. I already know 2 is not a factor, so 6 isn't certainly going to be a factor either. Now, I haven't done anything with 7. Is 7 a factor of 89? It is. Check that again. Excuse me. Oh, okay. Yeah, 7 is 7 is not a factor. Now, here's my contention. Having just checked those numbers right there, this number is prime. Because 8 is not a factor, and 9 is not a factor, because those are, if 2 is not a factor, then neither is 8. If 3 is not a factor, then neither is 9, because multiples of 9 are also divisible by 3. Since none of these are factors, those are the only ones I have to check. Here's why. What's the square root of 89? It's 9.3 or 4 or something, right? Square root of 89? What's the square root of 89? Somebody got it? 9.3? Make me do it? Okay, you don't make me do it. Oh, I put it in my pocket. 9.4. Okay, thank you. You see, I made it up to my square root, haven't I? How do I know there's nothing on this side that's going to be a factor? Well, if there's something greater than the square root as a factor, then what's true about less than the square root? There's something that's a factor less than the square root too, isn't there? So if these aren't factors, then there's nothing over there that's factor. Now, I shrunk my list way on down. What are these numbers really that I have to check? Aren't those primes less than the square root? Turns out, if you're checking a number for primeness, all you have to check are the primes up to the square root to see if those are factors. To determine if a number is prime, if you're just looking for whether it's prime or not, just check the prime numbers up to the square root. Okay. That's all you have to check for primeness. So is 1081 prime? Big numbers. A little bit bigger numbers here. But if I'm only checking up to the square root, the primes up to the square root, what am I going to have to check here? Well, what's the square root of 1081? 32.8. All right. So I'm only going to check 2. Well, 2 is obviously out. 3. Is 3 a factor? I don't think so. 5. No. 7. I am checking 7. 7, divide that into 1081, see if it goes evenly. Doesn't go evenly, does it? Got a remainder, decimal. Then go to 11, check it. No. 13. Have to check it. Doesn't go evenly. 17. Does that go evenly? No. Okay. Got a remainder. 19. 1081 divided by 19. Checking it. No. What about 23? Aha! So this narrows it down quite a bit. We reached 23. We hadn't quite made it to the square root yet, but we find out this is a factor. What does that tell me? Not prime. I found a factor. So yeah, if you get these bigger numbers and you're looking to see if it's prime, all you have to do is check the primes up to your square root. There you go. Now, let's do this one. Is 467 prime? Same deal. Let's check our primes, but this case we only have to go to what? Square root of 467? Which I get to be 21.6. So let's check 2. Obviously no. 3, no. 5, no. 7? 7 a factor? No. Doesn't go evenly. 11? No. 13? No. 17? No. 19? No. I've reached the square root. There's no more primes less there than the square root. None of them are factors. So I can safely say what now? 467? That is prime. Okay? Yeah. So once you just go through this list, I mean 467 is a pretty big number, but for primeness, all I have to check are 8 numbers. Those 8 numbers. And you safely can say your 467, that is a prime. Okay. Now, here's another way. Here's another way we can write primes. There's use primes. Interesting